Welcome to Basic Aerodynamics. Let's start with a small demo. We can see that the paper airplane is thrown at an angle upward, so the wing has an angle to the air in front of it, which provides an upward force called lift. At the peak, the plane has less speed and thus the lift has decreases, causing it going down and landing on the ground. The center of gravity is located in the front of the paper plane, since there are more weight in the front, and this gives a similar design to the airplane wings. As a comparison, we also have a demo of bad aerodynamics. We destroy the paper airplane and make a ball instead. Ball has little uplift since the air below it cannot support such massive weight. We can ignore the aerodynamics on it and it became a projectile motion, which travels less distance than the paper airplane that has the same weight. Now let's take a look at the design of aircraft. The design of the wings of aircraft makes the wing creating lift even when aircraft does not have an angle to the ground. The air goes through the top of the wing faster than the one goes under the wing as the air on top traveled more distance. This will create an upward force to lift the wing. Lift does not exist without air, which is why the wings of the Space Shuttle Orbiter were useless in the vacuum of space, but essential during its unpowered descent to Earth.
From Bernoulli's principle, there are two types of pressure created from a steady moving fluid. These are the dynamic and static pressures. Within a system, the total pressure is the combination of static pressure, which acts equally in all directions, which will affect the tube walls, and dynamic pressure, which acts mainly in the direction of the flow. Assuming no losses in the system, the total pressure would stay the same throughout the fluid. When we are increasing the speed of a fluid, this will increase the dynamic pressure, effectively reducing the static pressure. We can see it in the diagram as well. When the tube constricts, the fluid speed will increase since the flow rate is the same. When this happens, the static pressure becomes lower than the part with a bigger cross-sectional area. When the area of the tube increases back, the fluid speed will drop and increase the static pressure. Here's a small demo to visualize this principle. In the demo, we can see this principle come into play. The part being blown would have a lower static pressure due to the increase in speed compared to the surrounding air. This will create a pressure difference, pushing the paper into the region with lower pressure. This principle is also why uplift is achievable in planes. The force creating the uplift is caused by the difference in static pressure rather than dynamic, which causes the wings to get pushed upwards.
We are going to talk about downforce, specifically in F1 cars. So, what is downforce? Downforce is a lift force towards the ground created by the aerodynamics of the vehicle. It can improve the grip of the car and provide higher speed at turning. There are three main parts which provide downforce: front wings, fore, and rear wing. We are going to talk about the front wing first. Front wing is basically like a reversed airplane wing. So air, as the car is accelerating, gets directed to different directions. On top of the wing, air are directed towards the engine intake and tire to cool them down. There will be higher air pressure on top of the wing because there are air got blocked and redirected. And on bottom of the wing, they are accelerated towards the venturi tunnel on the fore, and it will reduce air pressure under the wing, which the downforce is generated by the difference of the pressure. And now we're going to talk about the fore, which it will introduce the ground effect, which the air accelerated under the front wing, it will fall under the car floor. And the air will pass through the venturi tunnels I can see on the bottom left graph, and it will get out from the rear diffuser, got accelerated even faster due to the Bernoulli effect. It will further reduce the air pressure and create downforce. Note that on the top photo, there are red arrows. It is used for air to block the dirty air towards the tire. Now we're going to talk about the rear wing. Rear wing works very similar to the front wing, but there's no need to direct airflow. The only purpose is to provide a better downforce. The top half also provides higher pressure as the air blocked and redirected, and lower half reduces the air pressure. As you can see here, there are side plates on the rear wing. This is called the end plate. It used to reduce the vortex introduced by the air spills over the end of the rear wing. What will happen if the downforce are not balanced? This will happen. Don't worry, no one is harmed during this event. And thanks for watching the project.